Hello, this is Mrs. Pullen. This is day 4 of Unit 3, more on graphing polynomials. And I'd like to do example 5, which is fairly representative of today's lesson. So the first thing you're given is you have this cubic polynomial, and you know that x plus 4 is a factor. And the first thing you're asked to do is using that information to factor this polynomial completely. And so the first step of this process is to use long division to find the quotient. So since you have a lot of experience doing that at this point, I'd like you to put the video on hold and try that. If you didn't match the answer, please look at this process, or otherwise you can skip to the next item. You should have ended up with a remainder of 0, and here's the quotient. So far, I know the factors of this polynomial p of x are x plus 4 times 2x squared minus 4x plus 2. But I can factor this quotient. I'm going to first factor out a GCF of 2, and I'm just going to put it in front of the other factor of x plus 4. So when I divide each term by 2, I get x squared minus 2x plus 1. But I can see that I can factor this polynomial further. Two factors that add to negative 2 and multiply out to 1 are x minus 1 times x minus 1. So therefore, this entire expression can be written as 2 times x plus 4 times x minus 1 squared. And that's for part A. To get the end behavior, we notice that our degree of our polynomial is 3, and our leading coefficient is 2, which is positive. That means that the graph is going to rise to the right and fall to the left. I now need to identify all x-intercepts. So I'm going to just switch colors so it's a little more obvious. Whoop, I thought I switched colors. Let's see. That's better, right? So what I'm going to do to get my x-intercepts is I'm going to take that factored polynomial and I'm going to set it equal to 0, and I can solve these linear equations. So this is equal to x negative 4, so that's first intercept, and since the exponent of this factor is 1, or multiplicity is 1, that means the graph is going to pass through. And the other intercept is 1, but its multiplicity is 2, meaning that it's going to bounce off of the graph, or we say it kisses the x-axis. Some of you have asked, well, what about the 2? Although 2 is a factor, it doesn't contain a variable, so it doesn't have an x-intercept. To get the y-intercept, and again I'll switch colors so it's easier for you to see, you're simply going to substitute 0 either into the factored form of the equation or the original form. And so therefore the y-intercept is 8. And now, once we have all that information, we can actually sketch the graph of this. So let's go to the next page. Whoop. So I don't have an actual grid, so just give me a second. So you're not required to have a graph, so we're going to just actually sketch it. So this is certainly what you're going to do a lot next year. On my test, you will actually have a grid. And so now let me get the pen out. And so you want to graph, you need a y-intercept of +8. Let's make sure to label the x and y axis. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to graph our y-intercept. And we need a y-intercept, x-intercept of -4. And an x-intercept of 1. So we're graphing those 3 points, and we know the M behavior is it falls to the left and rises to the right. And it's going to be passing through at -4. It's going to pass through the y-intercept, and then it's going to bounce at 1. And here, ladies and gentlemen, you have a beautiful graph. Enjoy!